Hello, my name is Yasukazu Suwa. I'm present about amplifier mechanism. So let's get started. So operational amplifier or op-amp is, as they are more commonly called, uh, one of the basic building blocks analog electric circuit. So in this presentation, I will share the operational amplifier, a linear device which have all the properties required for a nearly ideal DC amplification. They are used extensively in signal conditional filtering to perform the mathematical operations such as add, subtract, integration, and differentiation. An operation amplifier or op-amps for short is fundamentally a voltage amplifying device designed to be used with external feedback components such as resistors and capacitors between its output and input terminals. These feedback components determine the resulting function or operation of the amplifier, and by virtue of the different feedback configuration, whether resistive, capacitive, or both, the amplifier can perform a variety of different operations, giving rise to its name of operational amplifier. An operational amplifier is basically a three-terminal device which consists of the two high-impedance inputs. One of the input is called the inverting input, marked with a negative or a minus sign. The other input is called the non-inverting input, marked with the positive or plus signs. A third terminals represent the operational amplifier's output port, which can both sink and source either a voltage or current. In linear operational amplifier, the output signal is the application factor known as the application gain multiplied by a value of the input signal, and depending on the nature of these input and output signals, there can be a four different classification of operational amplifier gain. So this is for different classification of operational amplifier gain. One is voltage, current, trans conductance, and trans resistance. Since most of the circuit dealing with the operational amplifier voltage amplifier, we will limit this presented to voltage amplifiers only be in and be out. The output voltage signal from the operational amplifier is the difference between the signals being applied to the individual inputs. In other words, an op-amp's output signal is the difference between the two input signals, as the input stage of the operational amplifier is in the fat differential amplifier as shown below. So next, the differential amplifier. This circuit shows the generalized form of the differential amplifier with two input mat V1 and V2. The two in the identical transistor TR1 and TR2 are both based at the same operating point with their emitters connected together and return to the common race, minus VEE by way of resistor LE. The circuit operated from the dual supply plus VCC and minus VEE, which ensure the constant supply. The voltage that appears at the output out of the amplifier is the difference between the two input signals as the two base input and the anti-phase with each other. So as the forward bias of transistor TR1 is increased, and the forward basis of transistor TR2 is reduced, and vice versa. Then if the two transistors are perfectly matched, the current flowing through the common emitter resistor RE will remain constant. Like the input signal, the output signal is also balanced, and since the corrector voltage either swing the opposite direction or in the same direction, the output voltage signal taken from between the two collectors is. Assuming a perfectly balanced circuit, zero difference between the two collector voltages. This is known as the common mode of operation, with the common mode gain of the amplifier being the output gain when the input is zero. Operational amplifier also have the one output of low impedance that is referenced to common ground terminal, and it should ignore any common mode signal that is. If an identical signal is applied to both the inverted and the non-inverting input, there should no change to the output. However, in real amplifier, there is always some variation, and the ratio of the change to the output voltage with regard to the change in the common mode input voltage is called the common mode rejection ratio, or CMRR for short. Operational amplifier on their own have the very high open loop DC gain, and by applying some form of negative feedback, we can produce an operational amplifier circuit that has the very precise gain characteristic that is dependent only on the feedback used. Note that the term open loop means that there are no feedback components used around the amplifier, so feedback path or loop is open. An operational amplifier only records responds to the difference between the voltage on its two input terminals, known commonly as the differential input voltage, and not to their common potential. Then, if the same voltage potential is applied to both terminals, this resultant output will be zero. An operational amplifier gain is commonly known as the open loop differential gain and is given the symbol AO. So this video shows an evaluated circuit of the ideal operation amplifier. So I will talk about op-amp parameter and ideal characteristic. So first, open loop gain. The main function of the operational amplifier is amplify the input signal, and the more open loop gain it has, the better. Open loop gain is the gain of the open amp without positive or negative feedback, and such as the amplified gain will be infinite, but typically real values range from about 20,000 to 200,000. So next, input impedance. Input impedance is the ratio of input voltage to input current, and it's assumed to be infinite to prevent any current from flowing from the source supply into the amplifier input circuitry. Real op-amps have input leakage current from the few picoamps to the few milliamps. Next, output impedance. The output impedance of the ideal operation amplifier is assumed to be zero, acting as the perfect internal voltage source with no internal resistance, so that it can supply as much current as necessary to the load. This internal resistance is effectively increased with the load, thereby reducing the output voltage available to the load. Real op-amps have output impedance in the 100 to 20 kilo ohms range. So band-wise, an ideal operational amplifier has an infinite frequency response and can amplify any frequency signal from DC to the highest AC frequencies. So it's therefore assumed to have the infinite bandwidth. With real op-amps, the bandwidth is limited by the gain bandwidth product dB, which is equal to the frequency where the amplifier gain becomes unity. So last, offset voltage. The amplifier's output will be zero when the voltage difference between the inverting and the non-inverting inputs is zero. The same or when both inputs are grounded. Real op-amps have some amount of output offset voltage. From these idealized characteristic above, we can see that the input resistance is infinite, so no current flows into either input terminal, and that the differential input offset voltage is zero. It's important to remember these two properties, as they will help us understand the working of the operational amplifier with regard to the analysis and design of op-amp circuits. However, real operational amplifiers, such as the commonly available UA741, for example, do not have the infinite gain over bandwidth, but have typical open loop gain, which is defined as the amplifier's output amplification without any external feedback signal connected to it. For typical operational amplifier, this open loop gain can be as high as 100 dB at DC. Generally, an op-amp's output gain decreases linearly as frequency increase down to unity gain or 1 at about 1 MHz. This effect is shown in the following open loop gain response curve. So in the summary, we know that now that operational amplifier is very high gain DC differential amplifier that use one or more external feedback networks to control its response and characteristic. We can connect external resistors or capacitors to the op-amp in a number of different ways to form basis building block circuits such as inverting, non-inverting, voltage followers, summings, differential, integrator, and differentiator type amplifiers. An ideal or perfect operational amplifier is a device with a certain special characteristic, such as infinite open loop gain AO. Infinite input resistance R in, zero output resistance R out, infinite bandwidth 0 to infinity, and zero offset. The output is exactly zero when the input is zero. So there are a very large number of operational amplifier ICs available to suit every possible application, from standard bipolar, precision, high speed, low noise, high voltage, etc. in either standard configuration or with internal junction FET transistors. Operational amplifiers are available in IC packages of either single dual or quad op amps within one single device. The most commonly available and used of all the operational amplifiers in basic electronics kit and the project is the industry standard Micro A741. Learn more about operational amplifier basic and different types of circuit configuration you can construct using the Micro A741. So thank you for listening. Bye bye.